Welcome to my project.com. Now we are going to discuss about the optimal placement of multi-distributed generation units, including different load models using particle swarm optimization. Now I am going to explain the concept of this process. Optimally determining the size and location of multi-distributed generation unit for improving power quality using EV-MOGA. To determine the size and location of multi-distributed generation multi-DG units in distribution systems with different load models, EV-MOGA is used for an optimization algorithm. 38 bus radial system and an IEEE 30 bus meshed system is tested in the proposed algorithm. This is the flow diagram of our process. First, we have to create the general structure of the IEEE 30 bus system. The next one is the DG model, that is distributed generation model. It's also called an on-site generation, dispersed generation, embedded generation, decentralized energy. Distributed energy or district energy generates electricity from many small energy sources. Most countries generate electricity in large centralized facilities such as fossil fuel, coal, gas power, nuclear, large solar power plants or hydropower plants. These plants have excellent economies of scale but usually transmit the electricity long distances and can negatively affect the environment. Distributed generation is what Thomas Edison invention with his DC generators. A power station on every city block, making long distance transmission and its associated losses irrelevant. Then it has so many categories: reliability, flexibility, upgradability, economy of scale, diversity and efficiency. The next one is the EV-MOGA. EV-MOGA is nothing but the multi-objective evolutionary algorithm has been developed by the Predictive Control and Heuristic Optimization Group at University. Is an elitist multi-objective evolutionary algorithm based on the concept of epsilon dominance. EV-MOGA tries to obtain a good approximation to the Pareto trend in a smart distributed manner with limited memory resources. EV-MOGA based on the evolutionary principles. Representation GS operate on codes. Binary gray permutation real program. Fitness function relative quality measures of a solution. Objective subjective co-evolutionary. Population candidate solutions individuals. Genetic operators selection, recombination, mutation and replacement. Selection means the survival of the non-dominated. Recombination means combine the parental traits to create offspring. Mutation means to modify an offspring slightly. Replace parents with the offspring is called replacement. The next one is the different loads. Different loads means here we denoted as linear load, residential load, commercial load, dynamic load. First we see few loads, that is linear load. A linear load takes a current proportional to the voltage applied. If increases the voltage from 10 volt to 20 volt, current should double an AC electrical load in which both the current and voltage waves reach their peak simultaneously. It's also referred to as in phase. Linear loads are necessary to achieve maximum efficiency. The next one is the dynamic load. If our design is static, means we didn't change according to our requirements. So supply dynamic load means it's more efficient and the system is applied to the all conditions. A dynamic load is the forces that move or change when acting on a structure. Then the last one is the performance analysis. We go for the performance analysis. So analyze the different various loads as well as the comparison between the algorithm. Let's discuss about the implementation work of this process. This is the MATLAB command window. These are the function files used for this process. Main is the main function file and the others are the sub-function files. Choose the main function and click the run file option. Those are the processes going on and results we got. From this, we conclude that the results show that the proposed algorithm is capable of optimal and fast placement of distributed generation units. Then the efficiency of the algorithm is also improved. By using this algorithm, going to improve the power quality by the optimal placement of DG. Finally, we get an optimized result. Thank you. Results obtained from this process. In this first figure denotes the analyze about the iterations and the multi-objective functions used here. Iterations means how many times the process is going, and the multi-objective functions means the objective function problem is overcome by using these functions. Then various loads are used there. Here now we describe the three loads: industrial load, residential load, and commercial constant load. So finally we get an analyze about the three loads. Then the next figure analyze the performance analysis. That is, so we consider the 30 bus system and 38 bus system here. Then in 38 bus radial system we use different load models and note the how DG placement power value and non-DG placement, real power and reactive power, then system with DG and MVA without DG, and finally analyze the value of MOF, that is multiple objective functions. So these are the constraints we finally find out for all these tables.